Hi, Nancy.
Hey, Shane.
How you doing today?
My low level of enthusiasm, you can probably tell, is because we are a week and a half before our giant AGU fall meeting.
Yeah, that's not like that's not
Not
like
that I'm not excited for the meeting. It's just a lot of stress right now.
No, it's fine. We're completely
Yeah.
fine. How do you deal with stress? Like, what does stress look like for you?
I feel like I get very serious and anxious and you know what I mean? I'm not my jolly self. I mean, someone said the other day, you're not smiling. What's wrong? I'm like, I'm very stressed.
Just all happiness just drains from your life.
Yeah.
Yeah, I think I might get a little bit more serious. I just eat crappier. Like, I'm not necessarily eating more or less. It's just worse, like cupcakes and candy and just whatever's around.
I wonder if animals do that too.
I wonder. Welcome to the American Geophysical Union's podcast about the scientists and the methods behind the science. These are the stories you won't read in a manuscript or hear in a lecture. I'm Shane Hanlon.
And I'm Nancy Bompey.
And this is Third Pod from the Sun. Okay, so now I'm interested about this whole other animals getting stressed thing. And I think our producer, Lauren Lipuma, can answer this for us. Lauren.
Hey, guys.
So, what you got?
Yeah, actually, I met a professor. Well, actually, Shane, you and I both met a professor.
We did.
Earlier this year at Oregon State University. Her name's Leigh Torres, and she studies stress in marine mammals.
Ooh, so they get stressed too, like
They
us.
do.
What causes their stress?
Well, just listen and find out.
My name is Leigh Torres. I'm a professor at Oregon State University, and I do research within the Marine Mammal Institute. I study whales and dolphins and seabirds, mainly, basically trying to understand why they go where they go and how they find food in the great big ocean.
Mm-hmm. So how did you kind of get into this work to begin with? Did you
whale work? Or?
Yeah, whale work.
I grew up in Miami and always really curious about the ocean, and I also really like animal behavior. I've always been interested in all sort of mammals, large animal behavior. Mm-hmm. And at some point in my college career, I realized that people actually study whales and dolphins for a living, and I was like, wow, I want to do that. And so, yeah, from then on, I just sort of had internship after internship and field project, and then got a job, and then went to grad school. But just sort of kept going down the path, and landed here, amazingly.
So, I mean, you've obviously studied whales. You've studied whales for a long time. So how, for someone who doesn't know much about whales, how can you tell the difference between whether they're feeding or whether they're doing something else?
Yeah, it's hard. A lot of it's intuition, because from a boat we get, pretty much just a horizontal view of them, for the few moments at the surface. These animals, they spend more than 90% of their lives below the water. So we have to basically take what we can see from the surface and make some guesses about what they're doing below. So one thing we look at is their movement patterns. So if they're sort of moving in a straight line over and over, they come up to the surface, they take a few breaths, and then they go down, and then they come up, 4 minutes later, let's say 200 meters away, and they do that again. Okay, so that's in a traveling mode. But if the animal sort of surfaces irregularly, but in sort of a same general area, and is doing what we call fluke out dives. So that's where the animal sort of raises its fluke all the way up so it can get a more vertical profile when it dives down. That's another sign that it's likely feeding, because it's going straight back down into the water to feed on whatever's below it. So those some of the markers that we use to try and guess at their behavior. But now, so the really cool thing is now with drones, we're getting this wonderful new perspective from above. So it's really opened up this whole new vocabulary of foraging tactics that we talk about that the gray whales are using. So before we just would say, oh, they're feeding. We think they're feeding. But now with the drone, when the water clarity is good enough, we can see through the water to see how the animal's maneuvering underwater. So whether it's doing a headstand or side swimming, or we've even seen the whale swim upside down for minutes on end.
Wow.
Yeah, and so it's pretty amazing. We've seen them sort of jaw snapping and swimming along with their mouth open. So some interesting behaviors that really haven't been documented before. And so the drone has allowed us this wonderful new perspective, and we get 3 to 4 times more observation time than we do just from a boat.
So when we talked on the phone, you told me a little bit about how the drones can also tell you kind of like the about the whale's body shape, I guess. And what does that mean?
Yeah, so what we call it body condition. Basically, we measure how long the whale is and compare that to how wide the whale is. And we've developed what we call the body area index, which is akin to BMI in humans. So it's this sort of length invariant metric to say how fat and happy a whale is. So the higher the BAI, the body area index, the sort of fatter the whale is. And so we've been able to use that to look at individual whales and see how throughout a feeding season they have gained weight. And also at a population level as the months go on, the animals get fatter and fatter. And so that's really important because these whales, they really only feed for 5 to 6 months of the year, and they have to gain about 15 to 20% of their body mass in that period. So their ability to put on that weight is super important because that sustains them for the other 6 months of the year when they're not really eating.
About a week out from Thanksgiving, a week after Thanksgiving, and I still feel like I have about 15 or to 20% more body mass.
Oh, definitely. And like we said, with fall meeting, it seems like there's like cupcakes, free breakfast. And then at the fall meeting itself, I don't know what I turn into. But do you do this? Like, I just eat. Like, if there's food there, I just eat it.
Absolutely. Anything that's in front of me, I'll eat it.
I started drinking Red Bull last year.
Wow.
You don't even drink Red Bull?
No.
That's impressive. Well, I mean, like part of this, it's. I mean, holidays are also stressful, right? Or they can be stressful. They don't have to be. And part of that might have to do with how loud everything is.
Oh, yes. I'm Italian, so my holidays are very loud.
Screaming at each other.
Yeah. It's actually funny because when we were talking to Leigh, she was saying how mammals actually get stressed out by a lot of noise. So how do you tell if a whale is stressed out?
It's very hard because you can't ask them. We are looking at their hormone levels, and we're doing that by collecting their fecal samples.
So, okay, well, so tell me about that. How do you do that? And how do fecal samples tell you about their hormone levels?
Well, we have a lot of different hormones in our fecal, all of us. And I say we because we as mammals. So, and we can look at those different hormone levels. So there's reproductive hormones as well as stress hormones and a whole lot of other hormones that can tell us about how our body's functioning. And so the same is true for whales, that we can get a sort of a little window into their biology by looking at their hormone levels in their fecal samples. So in humans, there have been some biomedical studies, some studies that have shown that people that live in areas with elevated noise have compromised immune systems, so sometimes higher disease rates, higher cancer rates. And they've also been biomedical research showing that people that live in noisier areas have higher stress levels. And as we know, there is a connection between stress and our health. So all of that played into my thinking for this project.
So you think that the whales might have higher stress levels because of the noise levels of the ocean?
That's the hypothesis, and so we're trying to figure out if that's true. There was a groundbreaking study, which I've tried to emulate here, on the East Coast working with the North Atlantic right whale. So they're one of the most endangered whale species in the world. There's less than 400 left.
Wow.
And they live in this really urban environment where there's a lot of shipping traffic. And so these people from the New England Aquarium had been collecting their fecal samples for many, many years. And they had an idea, like I just mentioned, of the baseline of the stress levels for these whales. But then 9/11 happened, and all of the shipping traffic and air traffic across that region was shut down for, I think, at least a week. But they went out and they continued fecal sampling. And what they saw was that the cortisol levels, the stress levels of these whales just plummeted. It went so far below what they even thought was the baseline.
Wow.
Yeah, so that was our real first indication that noise is impacting, the physiology of whales.
So what specific hormones are you looking for in the whales' fecal samples?
So the main one is cortisol. and that's also a main stress hormone in humans. There's others. There's corticosterone, but for us, cortisol seems to be the best marker of stress in whales from what we know so far. And it's quite abundant in their fecal samples, so we can get a good measure of it.
So have either of you guys had any real dirty jobs, like where you do, deal with some yucky stuff?
I would say absolutely yes.
Yeah? What's yours?
Yeah, back when I worked in a research lab, I worked at a hospital and I had to analyze fecal samples from patients.
Oh, actually,
Yeah.
I have friends of friends who work for, they call it the poop bank.
The poop
And
bank.
the poop bank,
Interesting.
and it's all about like human fecal transplants to
That's a
reset,
full-on
See,
thing.
that's what we did.
reset
we
the
did
microbiome.
we did
Yeah.
like the precursor to that. Yeah, we were looking at what was in the poop first to see if we could transplant it.
I don't know if I'd want to deal with human poop. I worked on a horse farm for many years, and so I've definitely shoveled my fair share of horse manure. And you just kind of become like, I have a dog now, and I think nothing of it. Like, it's not a big deal. Picking up
Yeah.
that poop is nothing after picking up like, I don't know, 5-10 pounds of just visualize this.
Yeah. I'm definitely desensitized to gross things and poop now. But I have to say that collecting whale poop is probably a whole nother level.
Probably a little different.
Yeah. So how do you go about collecting a whale's fecal samples?
Yeah, well, you got to be patient because they don't poop on command. Unfortunately, I've tried. Trust me. Joe and I have been out there, wishing. Yeah, so our work involves finding whales, which for us is relatively easy. We work on gray whales off the coast of Oregon, and during the summer months, they're pretty easy to find. But then it's sort of a waiting game. We have other parts to our research. We do photo IDs, we do some drone work, we have the acoustic part. But then if we get all of that done, we sort of have to be patient, sort of tail the whale waiting for a potential defecation event.
Is that what you call it?
Or just poop, waiting for poop. That's the technical term in the field. Yeah. So yeah, and it depends on what else is going on, how long we'll actually wait. But for our gray whales here, we've had fairly good success. If the animal is feeding, that they do defecate, and so then when we see it, it's a big moment of excitement. Somebody yells out "poop," or multiple people do, and then we all jump into our roles. Which somebody drives the boat over to where the defecation is. Somebody else goes for the fecal sampling pole, and basically it's like a net on the end of a long pole. And we sweep it through the surface water where the fecal sample is.
Mm-hmm. So without getting too graphic, what is the whale poop kind of like? Is it more solid? Is it like amorphous? It has to be something there to scoop it out of the water, right?
Yeah, it's not as solid as we would like. And it's different for different whales, I should say. So I also collect fecal samples from blue whales, and there it tends to be more chunkier and solid at times. Gray whale poop, at least off the coast of Oregon, tends to be kind of diffuse, sort of liquidy mass of red fine material. There you go. That's the best description.
That's great.
It doesn't smell too bad. It doesn't smell like human poop or anything. It sort of smells like the ocean to me. So but it does sink rather quickly, which is why we have to get up there in the boat to sample it, because the more sample we get, the better our hormone analysis is.
Mm-hmm. And so how long do you usually have to wait if you're in a boat tailing this whale? How long do you usually have to wait, and after what point are you like, okay, it's not happening, we should just go home?
Yeah, so it depends on a whole mess of other factors. So if it's early in the day and we want to go and work with other whales, then we'll maybe not spend as long with the whale. If the whale isn't feeding, if it's like in a travel mode, then maybe we won't spend that long waiting for it. Like I said, if they're feeding, I have more confidence that they might poop relatively quickly. So, and then if the weather conditions are good, then we might want to work someplace else. So far, I think they're deteriorating. I'll, wait and work with this whale as long as I can. Mm-hmm. Yeah. So in terms of a time factor, maybe, so we do a lot of other work. So a sighting might last, 30 minutes to an hour. Mm-hmm. And, but after about that long, we'll probably give up.
Yeah.
But in that time period, we're doing other things. And
how do you decide whose job it is to hold the net and who's yelling out poo and everything?
Yeah, we do. We have, so we work in a pretty small research vessel. So there's typically 3 of us in a boat, so not very many. So we do have, roles. We have a driver and somebody with a camera, and then somebody that might go for the nets or the data recorder. And we all have multiple jobs. Yeah, and so, and we also, this year we started having 2 nets in the boat, which was good. So we have one with a long pole and one with a short pole. And so that's just doubled our sampling to try and get a bigger sample size.
Mm-hmm. So what do you store it in when you collect it?
Yeah, well, that's actually tricky. So, because once it gets into the net, it's sort of like this fine, slime, I guess, in the net. And so we have to get it from the net into a sample jar. And so the best method that we've come up with to do that is to actually use a squirt bottle and just with seawater, ambient seawater, and spray, sort of push the fecal sample from the net into the jar. And so we just have I think it's maybe an 8-ounce jar with a wide mouth that we push it into. Mm-hmm. Yeah.
Yeah.
And then store it on ice.
Yeah. So you've said you've been lucky to collect fecal samples from like the same whale multiple times. How do you find that whale again? How did you know it was the same whale?
Yeah, so is through photo ID is what we call it. So basically it's like fingerprint matching of their different pigmentation or scarring patterns. Mm-hmm. So some of the marks on the animals are really distinctive, and so when we're out in the field we can say, oh, that's Pancake, has this big huge white blotch on its side that looks like a pancake. Or Scarback has a big scar on its back. So sometimes we're out there and we know we're seeing the same animal, and sometimes later on when we look at the photos we match it up. But these whales do have high site fidelity, we call it, which means that they just come back to the same areas every year. And multiple times within a year. So what we've found is that we'll see Pancake, let's say, in June for a few days off the coast here in Newport. And then we won't see it for the month of July, but then in August, well, here it is, he's back again. And so we're able to get a better understanding about how these animals move in and out of areas. And then again, we get to sample how their body condition changed as well as their stress levels changed throughout that time period.
Mm-hmm. Is it different collecting samples for blue whales as opposed to gray whales?
Yeah, it is. Yeah, well, everything's different actually. It's just a different environment. So these gray whales, they live in really coastal environments here. I mean, they're right up against the coast in the surf zone. Mm-hmm. So these whales, the gray whales, they feed like in the rocks and up against the kelp, and so sometimes they're in areas that we just can't go safely in our boat. And then also because of the surf, the poo in the water gets churned up a lot more and sinks more readily. So the blue whales, this is more open ocean. It's an area in New Zealand, and their poo tends to be bigger poo events. So we have more, and it floats at the surface. So when they do defecate, we can typically get a bigger sample. But there, the whales are harder to find. They're just more dispersed. So unlike here where we can find the whales pretty easily.
Mm-hmm. Mm-hmm. Okay. Yeah. That's so great.
But essentially it's the same method. You got to find it, be patient, and then go for it. And with a net, yeah.
With a net.
This is really cool. I mean, maybe bad for the whales, but really cool. But what are they finding?
Well, so when I talked to Leigh, she was still combing through her data, and they hadn't yet made a connection between noise and stress, but they did actually have some interesting results about the hormone levels. Okay, so what have you found so far, when you're looking at, the stress hormone levels and their fecal samples and looking at the drone footage? Have you made a connection between the noise levels and their stress levels? Or where are you kind of
No, we haven't made any connections yet. We've sort of been studying our various data streams, as I call them, in isolation at this moment, up till now. The hormone work, we've been able to show that there's variability across the different individuals and different hormones. We've seen a correlation between some of the reproductive hormones and the stress hormones, which is what you'd expect. Animals that are pregnant have higher cortisol levels, stress levels naturally. Mm-hmm. We've seen how we've been able to collect poo samples from the same individual multiple times. So that's been really interesting to see how their hormone levels change or stay the same throughout different time periods. So because all of this work is really brand new, nobody's ever looked at hormones in gray whales before, we're really starting from scratch. So a lot of it we've had to develop the methods to do that, and also just understanding the baseline hormone levels of these animals. And then with the drone work, again, it's really novel new methods. So we had to come up with areas of quantifying body conditions. So that's the body area index, and looking at how body conditions change. So I think the next phase going into these next 6 months ahead of us is to link up those data streams. So stress, so we'll pair the stress levels with the noise events. So when a storm comes in, and it gets really loud in the environment, do we see a change in the whales' stress levels? And or do we see that skinnier whales have higher stress levels normally than the fatter whales? And so all of that will start to link together.
So what's your favorite part about it?
Well, one of my favorite parts is something we haven't even talked about. So we're also trying to understand what the prey variability is like, because obviously if there's low prey in a year, the animals will be stressed because of that, regardless of what the noise is like. So we've done a lot of GoPro drops. Basically, it's another cheap way to look at what's happening under the water. Or in the water. So we basically, when we're near whales that are feeding, I'll often just pause right there and put the GoPro in. It's on like a weighted stick. We call it this glorified selfie stick, that goes just over the side of the boat and goes down to the bottom. And then we bring it back up, after a couple minutes. And it's very qualitative, but I really love getting home and looking at that footage, because after being in a boat all day, I've been able to see what the whales are doing at the surface. I've been able to watch the drone footage. So I have this sense of the surface sort of behavior, but I don't really know what they're going down to feed on. So for me, when I watch that GoPro video, it's like the world that the whale sees when it dives down, and what the habitat like, whether it's rocky or kelpy or sandy, and what kind of prey it was and how patchy it was or how dense. And so that to me, again, is connecting those dots between what the whale is doing and why it's doing what it's doing. It's been an interesting journey. It's really the value in this project will be as a long-term project. So if we can keep it going for another couple of years, because these animals are really long-lived, so to be able to understand their actual natural variability in hormone levels, and then how environment impacts them, whether it's prey variability or noise, really will take a few more years. But we're slowly getting there. Yeah, I really enjoy the people we work with. It's a fun project, and it's great to have it here local in our backyard.
Yeah, absolutely.
So with all this talk about stress, by the time that everyone hears this, we'll be on the other side of fall meeting.
So wonderful.
I cannot wait.
I love fall meeting, but yeah, it's just like, it's a lot.
No, it's a lot of the planning, but when we're there, I feel like I actually say it's a lot like summer camp. It's like it's like that crazy, like, of course, it's like that crazy week where you're like so much fun, you see all your friends, and like you're so busy and crazy, and it's awesome, and then it ends, and then you kind of feel sad because you're like, sad and happy, kind of that feeling, which is how I feel about you guys. It's our first year anniversary of this podcast.
It is.
That's exciting.
Yeah. And this year is going to be awesome. 2019 is our centennial for AGU. We have special centennial episodes, and we have lots of awesome episodes in the regular series. So, yeah.
Yeah, you'll be getting 2-for-1 every month. That's exciting.
You can hear more of us.
2-for-1
You can hear more of me.
Which everybody's looking forward to. All right, folks, that's all from Third Pod from the Sun.
Thanks so much to Lauren for bringing us this episode, and to Leigh for sharing her work with us.
This podcast is also produced with help from Josh Beiser, Olivia Ambrosio, Liza Lester, Katie Brundle. And thanks to Adell Coleman for producing this episode.
We'd love to hear your thoughts on our podcast. Please rate and review us on iTunes. You can find it wherever you get your favorite podcasting apps, thirdpodfromthesun.com, and tell your friends to listen and subscribe.
All right, thanks all, and we'll see you next time.